So my voice is audible, right? Hello, anybody?
Yes, sir.
Yeah. So in this particular days on Saturdays, I will just try to address some of the questions that will help you in the particular to solve the particular assignments problems. So this is the first week one, that is on analog communications. So I think you guys have gone through the particular lecture notes. So the first one is, there is a question whether the power of my energy signal is always zero. I think my screen is visible, right? So you have to comment whether it is true or false. Please comment if my screen is not visible.
Yes, sir, it is visible.
Okay. So I want the answer also.
Sir, this is true.
Uh, okay. And then why?
Sir, we studied in signals and systems that the energy of an energy signal is finite and power of energy signal is zero.
And okay. So first, if I go through these, we'll just try to distinguish between a power signal and energy signal throughout the whole coursework. So the statement is correct actually. So the power of energy signal is always zero. So basically the reason I will just try to do. So what is the energy signal? And how we say what is a power signal type of thing. So we'll go by the examples, not by the definitions, because a lot of people gives a lot of definitions, and you can read from these. These are important things, but here I will go through some particular examples. So suppose this is a signal, and there is another signal, and it goes to infinite. So whenever a signal is an energy signal, so wait a minute. So that should be more of bounded kind of thing, because if we take from minus infinite to infinite and then we take mod of y t square dt, this should be less than infinite. So if we take this particular signal, we can say that it is infinite, not infinite, it's bounded by particular. So this is bounded, and we can say that energy is not infinite. We cannot say this for this signal. That's why we can say this particular signal has a particular energy. So the main motto is this should be bounded or it should converge to some particular value. But if we think about this signal, this particular pattern is getting repeated to the infinite. So it adds up for infinite number of times. And for that particular reason, we can say that if we calculate that mod of y t square dt, it will tends to infinite, right, for this signal. So this signal is not energy signal, because its energy is going to infinite, if we think like that. So for this reason, what people do actually, because the signal is periodic type of thing and the same pattern is getting repeated multiple times, so why should I bother about all the same repeating terms? So basically I have this particular term, and if I have this particular term, the rest of the things are the just time shifted version of the same particular thing. So what they do, they just say just divided by all the whole time period, and particularly take one particular moment of that one particular period of that particular signal. So here would come like I'll divide by all the t's and then I'll go from minus t to t. So suppose this is 0 to 2t, or probably this signal we can also say that if we do not take that particular y-axis here, we can say signal is like this, and from minus t to t. So what is the difference of that particular time period? This is 2t, and then I am just calculating the energy over this particular time period. So this will be actually equal to yt mod square dt. So this is actually the energy over this particular time period. And then we already know this particular signal is not equivalent to this signal. This is one particular periodic instance of this signal. So what should I do? So we say that this limit of t goes to infinite. So this is how the definition of power signal comes for this periodic type of signal. So what the question here was, the power of an energy signal is 0. So obviously if I calculate this particular power of this, but suppose we have energy signal, just writing it down. Suppose we have this particular this is only one instance, not multiple, because it is an energy signal. The question has already said that the signal is an energy signal. So if I want to calculate the power of this signal, so what happens? We have to take limit of t tends to infinite. 1 by 2t minus t to t mod of yt square dt. Now this term is finite, but this t is infinite, goes to infinite, right? But this term is finite for energy signal, this whole term. So something divided by infinite, that equal to 0. So this is finite, numerator is finite and denominator is infinite, because t tends to 0 here. The limit is t tends to 0. That's why if I say that what is the power of the energy signal, that is 0. But if this signal was not a energy signal, it was a power signal, at that case this whole integration term for each period, it will be infinite, because it repeats, then it also repeats. So it's not finite. This particular energy of this particular whole signal is not finite. So that's why power of an energy signal. So power is we see that this is a period, it only contains what is the energy of a periodic signal for a particular period. That is the main thing. So this power of this particular energy signal is always 0. I think it's clear for everybody. Anybody has any comment?
Sir, the energy is 9 to infinity y of t whole square dt, and then you said the power is calculated by taking the signal over a particular time interval minus t to t, and then we will do 1 by 2t. Why we are doing that?
Which one? Can you just tell me?
So in general case, like why is the formula for energy y t square dt, and why is the formula for power 1 by 2t y t square dt and
Okay.
integration y t square dt?
So your question is why the formula for energy is just only this for energy? Wait. So why this is the only formula for energy, and why if I take the whole term, why it is power, right?
Yes, sir.
Okay. So just take a sine signal. Okay. Sine of t, but not for the whole period. Okay. 0 to 2 pi. So if I take the mod square value, how it will be? So first you just square these terms up, so it will be more of like amplitude version of that type of thing, or something like that will come. And if I take for a particular instance, suppose 0 to 2 pi only, not after 2 pi it is repetitive. So after taking the mod, it will be something like that. Okay, but whatever, it will be within 0 to 2 pi, and after that it is not repetitive. Okay, so we can say that particular signal is within in particular finite period interval, finite period, we can say, not periodic, it's just a finite period, that is 0 to 2 pi. Now we can easily calculate. So what is energy? Energy is amplitude square or mod of yt square. This is the definition of energy. So if we calculate it from minus infinite to infinite, it will see equivalent to calculate it within 0 to 2 pi. And as this particular signal is finite within this particular duration, it will always be less than equal to infinite. And you can easily calculate the energy here. That is the energy.
Yes, ঠিক আছে.
Okay. So now if I go for this particular signal, and it's going to infinite, okay, it's never ending, because if I write sine t, t tends to infinite, sine t also exists, not in 0 to 2 pi. So similarly, what will be the power type of thing? It will continue to exist, right, to infinite. And then when you do the integration from minus infinite to infinite, and sine square t, mod of sine square t dt, you just cannot say it is bounded by infinite. But you know, for a particular instance within this limit, this will have a particular value. The same function, it will take the same value from whatever the value from 0 to 2 pi, that is the same value from 2 pi to 4 pi. The same value is repeated at 4 pi to 6 pi. In this way it is going. So the energy here is equivalent to energy here, is equivalent to energy here. But if I sum up all the energies, so if I say what is the energy of the sine signal, it adds up all the energies and it goes to infinite. So infinite, so energy becomes infinite. But if I tell that within a particular interval what is the energy, 0 to 2 pi, that is the thing, that is the energy that is periodically repeated. The same energy within 0 to 2 pi, from 2 pi to 4 pi, from 4 pi to 6 pi, and to infinite. It is finite. So what is power actually? Energy by time, right?
Yes, sir.
Are we here? Yeah. So within particular 0 to 2 pi, what is the energy? That is equivalent to 2 pi to 4 pi, the same energy. So that's why it is power actually. Within particular time interval, this is 0 to 2 pi. What is the energy? That is 2 pi to 4 pi. What is the energy? So this energy is repetitive. So why should I consider about energy? Where the whole energy is infinite according to this. If I take the whole thing, it is infinite. But if I take it part by part, it is finite. Right? So there is one quantity that can characterize the whole signal without talking about infinite, and that is power. And it only exists for the particular periodic signals. Even power becomes infinite if the signal does not converge, if it is not periodic. So suppose this is the signal. It goes like this. You can never say within this period and this period and this period the energy is same. So here power also does not converge. And we do not, these particular signals are not bounded. Okay.
Okay, sir.
So do you have any question? Please make it clear, because it is the fundamental thing for your coursework and future if you are a electronics and communication engineer.
So that is, we are taking 1 by 2t because the limit is from minus t to t. So that is why 1 by 2t.
Here it will be 1 by 2 pi. You can take 1 by 2t is equal to 1 by 2 pi here. Because sine is periodic from minus pi to pi, right?
Yes, sir.
You can, that I wrote 2t because maybe the signal is not sine. Maybe the signal is something else, but it's still periodic. Suppose the signal is a square signal like this, from minus t to t. Then we can may not be it is periodic within minus pi to pi. It's a generalization, we can say. Suppose t is a periodic signal from minus 3 second to 3 second for a square wave. In this case, it's still periodic, but not from minus pi to pi. I just gave you a practical example that pi can, for a sine signal, if 2t becomes pi and 2t becomes 2 pi. That's only the thing.
Okay, sir.
Is it clear? Any doubt? If you have any doubt, you can always, I welcome you to ask me the questions. It's not going to affect your grade, it's not going to do anything else.
And sir, why is energy amplitude square?
Oh, okay. So, what's the definition of energy? You are asking why the definition of energy is like that, right?
Yes, sir.
Okay, that's a good question. But energy is some quantity that quantifies how much, what should I say, because it's the definition of energy. So example, you can think like, suppose we have a particular signal like this sin t, and it should say how much, you are asking me why, how can I use the term energy. So how much quantity this particular signal has. So basically, if you just integrate over minus t to t, so suppose energy we had taken why it is x of t. We could have taken like this, right? You can say.
Yes, sir.
But if I take this particular format, you just do the integration from 0 to 2 pi. What will it come? It will come 0, because this area will cancel out this area,
Yeah.
right?
Yes,
So
sir.
that's why they take the mod square term here. If you square it, then what? How it will convert, right?
Yes, sir.
So that's why they are just taking from minus t to t mod square term, and then they are squaring up it. So it actually preserves what, how much amount of quantity this signal bears.
Okay, sir.
This can be a definition, but this is the definition of energy. That can I say.
Okay, sir. And sir, in the power you said we will integrate from minus t to 2t, so that's why we are taking 1 by 2t. So what if the period of the signal is only t?
Oh, period of the signal is only t. Okay, then it is from minus. It is a periodic signal from minus t to t by 2,
Yes.
and then it is t, right? So
Oh,
you just put it here, then t. I don't say 2t, and I at that time what is t? T is actually minus t by 2. I'm again saying it is just generalized version. So suppose uh, to clear your doubt, yours it is my generalized function. Okay, minus t to t. Now you are saying t is equal to some period t1 by 2, minus t is minus t1 by 2, and plus t is t1 by 2, right? It is the generalized
yes.
format. Otherwise you can write it like this: 1 by t minus t by, sorry, minus t by 2 to t by 2. The limits will only change, nothing else, the same signal.
Okay, sir. Okay, sir.
Because we will change the integration limit also at that time,
Yes, sir.
and the same thing, limit t tends to infinite.
Yes, sir.
Okay. second question, next question. Second question is whatever we have discussed till now. It is actually, you have to comment. So what's the comment on this particular energy signal is always finite duration?
Sir, this is true.
Ah, now something we have not discussed in the previous section. So your visualization of a energy signal was like that, but we said signal is energy signal is xt square dt is less than infinite, right? This was the definition of energy signal.
Yes, sir.
So this holds for this also, right? Because if we calculate particular, I know it is constant within particular time, so just we have to calculate from 0 to something t1. We have to calculate what is the value of within this 0 to t1 and xt square mod of xt square dt, and it will certainly come infinite. Some number finite, some finite number will come. Maybe it can be 10 to the power 29, but still it is finite because it is bounded by time.
Yes, sir.
So there can be any one type of another signal that we have not discussed it. So just take the example e to the power minus t. So what happens to this signal? So certainly for this type of signal e to the power minus t, for a large t, the signal actually vanishes, but not actually zero. It tends to zero. A very small quantity. And the signal converges. So see, this particular signal, if I take mod of yt square or minus infinite to infinite, is obviously less than infinite, because as t becomes infinite, it becomes zero, right? The signal is not t tends to infinite and it also becomes infinite. If t becomes infinite, this signal becomes zero. So we cannot say that this signal, if t goes to infinite, this signal is also not bounded. It is zero at that time. So it is finite at t equal to infinite. It is zero. But the signal is not for finite duration. It goes to infinite. So that's why this kind of signal can exist. And that's why here I should say it is false. Is it clear?
Yes, sir. Yes, sir.
Yeah.
So, meaning that some decaying asymptotic signals of infinite duration are energy signals.
How? So basically it needs to converge. You have to check whether at infinite it becomes infinite or not. That's the main condition still now. But there could be another conditions also for some signals. But mainly this is the condition. You have to check whether at infinite it becomes zero or not. If it does not become to zero at infinite, then at infinite it just gets adds up, and we don't have any idea about infinite. So infinite can be double infinite, triple infinite, and it goes beyond infinite. It becomes it just adds up, and if it gets adds up for infinite, the signal's energies also gets adds up. So this is not an energy signal at that particular time. Is it okay?
Sir, and
Yes.
you're, you're talking about the signal where, like, at t equal to infinity, yt equal to we don't know.
I, yt we know. Suppose this is xt.
Okay.
Xt and yt is same. You
Yeah,
know
yeah.
what is e to the power minus t. If t becomes infinite, it becomes e to the power minus infinite, and this is zero, right? You know.
Yes, sir.
But if it is not something, if it was e to the power t, then e to the power infinite will be infinite.
Yes, sir.
So this is not energy signal if it is e to the power t. But if I take e to the power minus t, see that this becomes zero at t equal to infinite.
Yes, sir.
And also one more thing I missed in this particular while discussing, because you actually e to the power minus t is also not converging, because we say that at t equal to minus infinite, e to the power minus t is infinite, right? So it's this signal goes like this. So from minus infinite it is coming. So we have to add another condition, e to the power minus t from t equals to 0, t equals to 0 to t to infinite. Within this interval it is converging. Is it clear?
Yes, sir.
Yes.
So the signal is an energy signal only for the interval it is
Ha,
converging.
ha. Whenever it is converging, it should be converging as converging sequence.
Okay, sir.
That is why this concept comes bounded input, bounded output, right? But you have to calculate, because somebody gives you a particular signal, then you have to show that somehow it is bounded within particular 0 to infinite. If it is not, it is infinite within 0 to infinite. You have to check whether it is a power signal. Even the power is infinite for a particular period. If you calculate like that, then you will neither it is an energy signal, neither it is a power signal. This is a, so just I will write. You basically have a signal yt. The first point is you go through yt square minus infinite to infinite and check whether it is finite or infinite. So if it is infinite, then you check its power. Again it comes whether it is finite or infinite. And then if it is infinite, it becomes neither energy nor power. So at every, it is finite, then it is energy. If this is finite, it is actually power. So it comes in this step by step process. Okay, so we can move to the next question.
So, but sir, here
Yes.
the example you gave that e to the power minus t, it is not converging for finite duration because for in the negative side it is going to minus
And
infinity.
that's why I told you, like, after from t equals to 0 to t equals to infinite, it is actually the sequence. I wrote it.
Oh, okay, sir.
Hello, sir. Am I audible? Hello.
Yeah, your
Sir.
voice is not actually audible. It's very low tune.
Okay. Hello.
Yes.
Yes, sir. So in the when t tends to infinity, not minus infinity, the
Yes.
signal is actually convergent, right? So e raised to minus t. Uh,
From t equal to minus infinite, I'm
from
not
t equal
understand.
to 0 to infinite. From the
Yes. Yes.
positive side, right?
For the
For the positive side of t.
positive side.
Yes. So it's converging, right? Not
Yes,
exploring.
in the positive side is converging, but you have to say that the signal exists from t equals to 0 to t equals to infinite. It does not have any component
Oh, okay, okay.
in the left side of t equals to
Oh,
0.
okay, okay.
Okay, so the next question. So what's the comment on this? Power signal can also be a finite duration.
So this will be
Okay.
false.
Yeah, this is false. Again, the same reason we have discussed for power signal. If power signal is a finite duration, then the from the definition it comes like limit t tends to infinite 1 by 2t minus t by t and yt square dt. If it is a finite duration, this particular thing becomes finite. Just hold a minute. I'll be back within 5 minutes. Hello. Yeah, yeah. I'll come. Just wait. Yeah, sorry for the inconvenience that created. So we are here, right? So this particular term becomes finite. My voice is audible, right?
Yes.
Anyone? Yeah. So this becomes finite. But see, there is a limit term, t tends to infinite. For that, this particular t becomes infinite. And ultimately it becomes finite by infinite. So it is some sort of a by infinite, and it is equal to 0. So it cannot be 0 for a power signal. Power cannot be 0. So that's why a power signal also cannot be of finite duration. It's false.
Sir,
Yes.
Sir, can you
sir.
repeat this once?
Yeah. It's better to repeat in this way. So what's the energy actually first? From minus t to t, we just take yt square dt. This is the energy. Then we are saying that energy is particularly periodic for a particular time instance. So just for each time instance, we are just checking what is the particular divided. We are dividing energy by time to get the power, and then we are saying that limit t tends to infinite, because the signal can go from 0 to infinite, and it may not converge for power signal, but still it's a power signal. So if the signal is of finite duration, we have already concluded this numerator term, this is the energy is finite. So if I do not think about these two terms, only this term, the black one, it is finite. But now the t tends to infinite, 1 by 2t. If I want to calculate this particular term, so this is 1 by infinite, because t tends to infinite. But this particular numerator term that it have, it is of into some finite term. So finite by infinite, what it comes? It always 0, because suppose this finite term has a quantity that is a constant a. So this whole term becomes a by infinite, and a by infinite is what? 0. But power cannot be 0, so this cannot be a power signal in that scenario. Is it okay, or what is the question?
Sir, may I know why we take the limit t tends to infinity? Is it because we are considering the entire time domain, or is there any particular reason for
Yes,
that?
yes, because that's the definition. Because you have to check for 0 to minus infinite to infinite, you have to check whether uh, for minus infinite to infinite, whether it is converging or not. That is the main constant for energy. If it is not energy, but still it can have particular, but it's still within minus t to t, it's constant, right? Because we are not taking minus infinite to infinite, we are calculating the energy within minus t to t only. That's the difference for power signal here.
Okay, sir.
So basically, if we had to calculate the energy, this will be minus infinite and this will be infinite. But as we are calculating the power, so we are actually dividing within particular time, and that's why we are changing the limit to t2 minus t. Or you can think it also like that. If you only want to calculate the whole energy, This is equivalent to it, this type of formula, but this is not mathematically correct, but for your intuition it is correct. Like you have to calculate for minus infinite to infinite range, that is 2t, and then you have to calculate minus infinite to infinite yt square dt, and this is the power for infinite period. We are only changing t2 minus infinite, minus t2 minus infinite, and t2 infinite. So if I just say that it is not infinite, it is a particular finite duration, it is repeating, so that formula comes from there. Is it okay, or do you have some doubt?
Yes, sir. Sir.
Yeah.
Sir, we are putting the limit t tends to infinity because the signal, like if it did not repeat from in minus infinity to infinity, then there would be no finite power. That's why.
No finite power in the sense. Can you repeat your statement once again?
No, sir. Actually, I'm a bit confused.
You should not be confused. That's why you should ask me. Ask me until even it is not clear for you. Mathematically, it's not clear for you. Where
Sir,
are you getting stuck? Tell me.
so why we are like he asked why we are putting the limit t tends to infinity.
Okay. So just clear everything here. What was the energy definition? From minus infinite to xt square dt. Why we are doing like that? Because suppose you have a signal t tends to infinite, we have to calculate what is the energy. This is clear for you, right?
Yes, sir.
So suppose we say that for a particular, this signal is like this also. This equation still holds. Then we say, oh yeah, this particular, within particular, this particular, after this particular period, it is the same energy coming again and again and again. So why not we just say that from minus, from 0 to 2t here. So we just calculate whether 0 to 2t, this is 0, this is 2t. Within this interval, we just calculate the energy here, right?
Yes, sir.
And then this is the same thing is repeating. So it goes to t tends to infinite. Okay. And then I have to divide what is the energy. This is the 2t duration. So 1 by 2t. So this is the power, right? Is it
Sir,
clear, or tell
so,
me?
so sir, the power signal is always periodic in nature.
Mode of, because it's within particular time we have, it's mode of periodic every time.
Okay, sir.
Otherwise we should not care about power, right? Because power will anyway will be zero, as we discussed earlier.
Yes, sir.
So basically, so there is no term here after that. Suppose it becomes like this, only this term, nothing else. So as t tends to infinite, all these zero terms will start to get added. And if we see at t equal to infinite, it is getting divided by 1 by infinite in this duration. And and this signal will have a particular energy for this particular finite instance. So this finite term is getting divided by whole big time, and it converges to zero. That's why power becomes zero for this energy signal.
Yes, sir.
Hmm. Next question we should go. Oh, this question is some form of mathematical equation. So, suppose we have a signal xt that can be written as a0 okay, let's write it below. So this is Fourier series representation, and also can be written as the same like xt is actually n equal to minus infinite to infinite cn exponential of minus 2 pi j n t by t. So you have to find the formula. How can you represent an and bn as a function of cn and cn minus n? So basically you have to represent n equal to, suppose n can be cn plus c of minus n, bn can be j of c of minus n plus n, this sort of things. But may not be it is the correct answer. Does not guarantee it is the correct. I just give you an example. But what will be n and bn? That is you have to define. Okay, this is nothing about physical intuition. You have to just solve the Euler equation. I'm going to solve it actually.
So there is a lot of noise coming from someone's mic.
So someone mic is on. I think he's in bus or something, public transport. He's just listening from there. Can you just mute and just open your mic when you have any question? Okay. So just we start by the what is the from the Euler equation. So basically it was written as n equal to minus infinite to infinite c of n. Who is there? It's muted. He muted or C muted. I don't know. 2 pi nt by t. So if we just replace the Euler's equations, so xt becomes that is written as a0 plus n equals to 1 to infinite, and there was a term, this cost term. So we are just writing the cost term. How can I write the cost term? It is actually n by 2 e to the power j 2 pi n t by 2 t plus n by 2 e to the power minus j 2 pi n t by t. This is the term that it represents cos, whatever the term is, that's cos 2 pi n t was there, right? This term. I'm not writing the whole term again. Similarly, we can write it here. For the sine term also, we write it like this. N is equal to 1 to infinite and then Bn, the same sort of thing, but the complex term comes because Euler equation says e to the power j theta is equal to cos theta j sin theta. Or you just can write it. I just directly write it. For sin theta, I just give you the example. The sin theta becomes e to the power j theta minus e to the power minus j theta by 2j. This thing comes, and with that, it actually becomes e to the power j 2 pi nt by t plus, just remove this term for right now. I think it's clear. But here it is minus sign because we are talking about the sine term only. So this is b by n 2j exponential minus j 2 pi nt by t. So we can check that from, if we just equal these two equations, so Cn is actually it becomes an by 2 plus this term by 2j. C of minus n terms, or it becomes minus infinite when this terms comes, it is actually an by 2 minus bn by 2j. You just have to replace these particular coefficients and have to check what is this particular coefficient according to this. N equal to minus infinite and infinite. So n can take at n equal to minus 1 and n equal to 1, what the values that they are taking. So according to that, you can find what is c of minus 1 and c of 1, and then you can compare what is c of 1 and what is c of minus 1, and we will get this sort of equations just by replacing. So from here we can write just the equation will come like n equal to c of n plus c of minus n, and b of n is equal to j of c of n and c of minus n. So this is the equation, this is the formula that we are looking for. So the main thing you can notice here, that the key catch here in the Fourier series, that I will say that this Cn and C of minus n, and this is something multiplied by j and j of Cn and C of minus n. So when you just add up these particular two sequences, they just brings a complex number here. Just simply they just don't add up. They just brings a complex number. So it becomes something C plus JD. You can think like that. And that's from where the expressibility of Fourier series comes actually. But you should particularly do it in by your hand. Just put c n is equal to -1 and n is equal to 1, or just put n and c of minus n and just express it in terms of Euler series. Like the Euler equations is like that. I think you know. So Euler equation says e to the power ix is equal to cos of x plus I sin x, and cos of e to the power minus ix, cos of x minus I sin x. These two equations you just have to put here. For n is equal to my n is equal to n and n is equal to minus n. Then you will get c of n from here, c of n, and you will get c of minus n from here. And then you have to compare the coefficients written here. And you will find these two. Okay. So this was more of some mathematical question. You have to solve it by in your hand and you will get more exposure to the particular equations. And that you should do, otherwise you will not get what is the actual theoretical interpretation for each mathematical interpretation. Okay, so we are going to question number 5. Let us go to the question number 6. Question number 5 is also some mathematical equation. So it is actually find out whether the following signal is a energy signal or power signal. Energy or power. So I'm giving it, signal is actually like this. It is actually exponential of minus at for t greater than equal to 0 and 0 otherwise. Now your task is to say whether it is a energy or power. And if it is energy, tell me what is the energy. And if it is power, tell me what is the power. So anybody? At least say whether it is energy or power.
So it is
Correct.
energy,
Energy is
as
it.
you said that in the previous example, it is energy.
So it's easy to calculate what is the energy. So let me calculate it. So as I said, what is the energy? Minus infinite to infinite. Take mod of yt square and dt. Then what if, just look at the signal. Signal is from t to 0. So the lower limit comes 0 and upper limit remains at infinite. And what is the signal here? Exponential of minus 80. So it is exponential of minus 280 into dt. And then you do the integration. 0 to infinite e to the power minus 280 dt. What it comes? First term becomes, for this upper limit terms it becomes 0, lower limit terms it becomes minus of minus 1 by 2a, 1 by 2a. Right?
So here we are not taking the mod of e to the power minus
You
280,
take
which
mod, it does not matter. It becomes the same value. Is there anything minus in front of it?
no,
So what was there? It is e to the power minus 80. So we squared it, it becomes 280. E to the power 80, the square is equal to e to the power 280, right?
yes sir.
So that thing I have replaced here.
So now in some cases we used to take the mod of e to the power 80, like it becomes 1 or something like that.
That is from Euler's equation. If I take mod square of this, but there is no imaginary
Oh,
term
acha,
here, right?
acha, acha. Okay sir.
Because what? This is why it comes 1. Because it is actually, I saw already told you, plus I sin x square. I sin x, right? Now
Yes
if
sir.
you take the mod square, what is become? Cos of x square plus I sin x square. So if I take the mod, then it's cos square x plus sin square x equal to 1. That's why equal to 1, right?
Yes sir.
It is okay. 1 by 2 it's coming from you, right? If you
Yes
do the
sir, it is.
integration. Uh, there is nothing like, I would say like, how it is coming, I don't understand. It's not like that. It's very easy. Just you have to be confident about it. Question number 7 is about some delta function question. I think if omega is equal to 2 pi f, then tell me the true statement. First one is del of omega is equal to 1 by 2 pi del of f. Option B, del of omega is equal to 2 pi del of f. Option C is del of 2 pi omega is equal to del of f. And option D is del of omega 2 by pi del of f. So what's the answer?
B.
No, B is not the right answer. Okay. So we're just going through by equation by equation. So what's the delta function actually?
Sir, can
Delta
you show
function.
the previous slide once?
Yes, this one.
Yes, sir.
Okay. Can I go right now? Just start to derive it.
Yes, sir.
Yeah. So what's the delta function according to you?
Uh, so
So it is the unit impulse function.
Okay. And what the other guy was saying?
so it's when it's integrated from minus infinity to infinity, it
Mhm.
tends to one. Uh, but
And where it becomes one?
because the initially we
Where
are
it
considering
becomes
a
one?
pulse. When
Where it
we
becomes
reduce the
one?
pulse such that the area is constant, and the
Okay.
pulse when t tends to zero, the overall overall amplitude tends to infinity.
Hmm. Okay. So basically, what I say, this is sorry, it's minus infinite to infinite. Suppose there is a point zero, and there is a infinite pulse. That's delta function, right? This is correct, right?
Ah, yes.
Yeah. So, and another property of delta function we know that if I multiply it f of x, what it will be? F of 0. Because at x equals to 0, it only holds the value, right? So it only take the value of f equal to 0,
Yes.
right? So this equation holds for delta function because it can only exist at x equal to 0. Then if we change the variables like this, del of x, f of x, dx, it's similarly multiplied by a infinite and a infinite. So this becomes similarly, it actually does not change, it is actually still infinite. So from this we can write it as minus infinite to infinite del of x into f of x dx. Similarly, from here we can actually write it is actually from minus infinite to infinite del of u f of u by a, and we just change the variable at a. So from this equation we can go minus infinite to infinite del of x dx is equal to 1 by mod of a f of 0 by a, or the simple version of this is actually del of ax is equal to mod of a del x. So this is the thing that I get. So this is the mathematical formula. So it's the scaling property of delta function. We say it is the scaling property. So actually, what is the visualization of this particular delta function? That is more important than anything else. So I'll just give you the visualization here. So what is delta function? Delta of x actually 1 for x equals to 0 plus to 0 minus a small vicinity. So basically, it's if I take the integration over minus 0 minus infinite to infinite dx, it becomes 1. That's the main definition of delta function. So if we just scale it up within this particular instance, so it is actually a particular area 0 minus to 0 plus, and if I integrate over this particular area, it will become 1. So if I just del of x, just do a scaling in the x axis here, what will it come? So to keep this value at 1, this particular value should decrease, because suppose we are increasing this region like this, so the height will decrease. So by the factor it will increase minus x to x. The height will also should decrease by that factor, by a, not x, so that the area remains constant under this delta pulse. Because the definition of delta pulse is from minus infinite to infinite, if I just do the minus infinite to infinite integration over it, some sort of, and it only stays at, sorry, I should not write it to minus infinite to infinite, because in that case it's actually 0 minus to 0 plus. Small vicinity, it's the area between 0 minus to 0 plus limit, within this limit, and within this limit it's a square pulse. So if we just say that it is a into 0 minus and a into 0 plus, this area should be decreased like that. So the total area remains constant, the value of the del function remains 1, but the magnitude just decreases by a factor of 1 by a. So that's why this is the physical intuition from where it comes, this equation we have derived on it. If you do a scaling in the x, it will just get divided mod of a for delta x. So that's why it is delta of x. So I also gave you the actually theoretical derivation here, and I also gave you the actually the practical visualization. So from here we can say that the option number A, data form,
Yes.
Yeah, the order
Zero. Yes.
Can you explain this part again, sir? Where so how are we getting that cos square omega t plus theta dt equal to half? And so that one also, how is cos omega t plus theta dt equal to 0? Yes, sir. Okay, sir. Yes, sir. I understood this. Okay, sir. Yes, sir. So can you stay on this slide a little bit? I am writing the lower part. Yes, sir. Done. So how did this part come? Can you explain that? Cos omega 1t plus theta into cos omega 2t plus theta 2 equal to the. Yes, sir. Yes. Yes. So cos of A cos of B equal to half into cos A plus B plus cos A minus B. Yes, sir. Yes, sir. Yes, sir. Yes, sir. Yes. So by 2. Sir, from which book should we practice? Okay, sir. Okay, sir. Okay, sir. Yes, sir.
Thank you, sir.